This is section 5.1, day 2, and we are still talking about area, fitting it all together. If you were there for day 1, we know that we're making area approximations using rectangles, so we're fitting rectangles all together here. We also can approximate, and that's enabling us to approximate areas when the region isn't geometric, so that's still our essential question for today. We're still approximating with finite sums. In other words, we're adding, because that's what the word sum means, we're adding a certain number of rectangles together. And so that's our essential question is still the same. And so we're going to try something for which we don't exactly have a formula for again. So here's a function that's a square root of x. And we are going to approximate it using rectangles, but we want the volume. So we want this, we want to make this into a solid by rotating it about the x-axis. And so that makes it a solid, and it makes these rectangles then circular discs. And so in your email, I've emailed you a video of how we can rotate this and make this into a three-dimensional shape. And so I'm going to have you view the video and come up with a strategy to approximate the volume and perform that calculation. And so because you can't access your email right now, I've included the video for this purposes. So you can see that the orange is the rectangular approximation, and the purple is that function, that square root of x function. And now I'm going to spin that square root of x function about the x-axis. So here, as we lift that parabola out of the x-axis and back down onto the x-axis, you can see that these cross sections are circular, and so these become discs. And so we get this, I call this a nose cone, because it kind of looks like the front of a rocket, or maybe it looks like the cone where a turbine sits for a jet engine. And so we can approximate that volume by adding up all of the volumes of those discs. And that becomes a geometry problem, because those discs are skinny cylinders. They almost look like little, cans of tuna or something. And so I'm gonna go ahead and hide these things. So here's hiding the approximation. We can see that's actual three-dimensional shape. And we can't get that volume exactly, not yet at least. We will learn how to do that. But right now we're just worried about approximating it. And so we're going to get the approximation by using the discs, the cylinders that we've generated by revolving this function. So let's bring the cylinders back into play and turn off the nose cone. So we've got all of these discs. So we've got all of these discs here that are, we have a radius that's equal to the function, and then have a thickness here that is equal to 0.5. And if you notice, because I've set this up for an LRAM, that we're actually missing that first disk here, because an LRAM would have a height of 0 at the beginning of the shape. So here's the radius of the function, and then here's the thickness of the disk. And so the strategy then to find the volume of that approximation turns into a geometry. So we're going to calculate the volume for each one of these disks then using our geometry formula for the volume of a cylinder. And that first one, since that would have, since it's an LRAM, this would have a height of 0, so we'd lose the disk here. And then we would have all of these heights of these disks here, the radius of the disks here. And that follows the contour of the square root pattern. So So we're going to go ahead then and approximate this area. We're going to find the function values at each one of these locations. And that is going to be the radius of the disk as this thing is revolved. So that's going to turn into the R value. And then the H is the thickness of the disk, which is 0.5. So there's that disk, and there's that R value, that radius that represents this rectangle, and then the height represents the thickness of that disk. And so then we can find a way to approximate the volume of this nose cone. And so why don't you go ahead and go through that process, and you should get a volume of 7 pi cubic meters. So check that you can get that volume. So after you complete that activity, then you are ready to finish up the homework for 5-1, days 1 and 2.